Hello guys, welcome to Pentesters Club. Today we are going to discuss some new topic, Boofuzz. So what is Boofuzz? Boofuzz is a network protocol fusing for humans. So Boofuzz is a fork of and full successor to the venerable of Sulley fusing framework. Beside the numerous bug fixes, Boofuzz aims for the extensibility of the goal of fuse everything. So why we need to use the Boofuzz? So it has been a preeminent of open source of fuzzer for some times, but has fallen out of maintenance. So in these features, we can see mainly easy and quick data generations, instrumentations, aka failure detections, target resets with after failure, recording of test data. We can record some test data. Unlikely, Boofuzz also have some more features like online documentations, support for arbitrary communications medium, built-in support for serial fusing of Ethernet 0 or IP layers of UDP broadcast. So better recording of test data consistent through a clear test results, CSV export, extensible instrumentations or failure detection, much easier install experience, far fewer bugs. We can find some far fewer bugs in this. Sulley is affectionately named after the giant heel and a purple creature from the Monsters Inc. Due to his fussiness, Boofuzz is likewise named after only the creature, known to have a scared Sulley himself. So we can look it out how this will work. So once we come for the Boofuzz. So in this Boofuzz for FTP transactions, like the publicly protocol libraries are free to open source. The implementations are not all close to the full protocol coverage. So Boofuzz file transfer protocol and Boofuzz HTTP. So Boofuzz FTP run FTP servers. Any server obscure of secure open source projects are a nice place to look for the bugs since we are trying to break the program. Anyway, you may not be run the virtual machine. So if you want to find the FTP of any of the domain, so this can be helpful with capturing the FTP also and HTTP. And so we look it out how this will work. So let's install the targeted machine Linux. So once you install, and you can look it out, Boofuzz network protocol. So here test the target connection is recess considered a failure case. So Boofuzz installs in the Python library built-in features in the installations and community kind of. So you can see here documentations. So we don't want much more about these things. So we run how it will be installed. So let's copy the source code. We copy the source code and let's wait how we can look it out. This one, open the terminal, git clone, paste it. List. So you need to install any requirements is there, look it out. So there is no any requirements is there, so you need to install pip install Boofuzz so it takes some time for installation. Successfully installed. So now clear this virtual machine control, or else how we need to run. So we need to set up first. So running install can't create or remove files in install directory. So we can remove this. So list process monitor VM control copy paste. So this only works on Windows. So why they mention virtual machine? Okay, we run Boofuzz directly. List. So here we can see mutations, utils, web, fuzzers.python. So we can run this fuzzers.python. Attempt to relate import to my parent package. So we didn't install any backend parent package. So we need to run directly from here. So parent package setup.python. So network monitor. So we can try network monitor. So yes, I'm waiting for a request. So we get network monitor device, a device to sniff on see the list below. So network devices with 172.0.10.10, Docker, Bluetooth monitor, NF log, dbus system, dbus session. So network list, I have this much network list. This network list. So if I go with the local host, so I can search only the local host. If I go with the Number one, any or else Bluetooth monitor. So if I share any Bluetooth, so it can be monitored also. So whatever they're transferring data from one systems to another systems, so I can capture that data also through the UDP protocol, and NF log and NFQ and the bus system. So we need to know the bus system. So the CAN bus protocol or its bus protocol can be summarized in the following manner. The physical layer uses for the differential transmissions on twisted pairwise on non-destructive bitwise arbitrations. It is used to control the access of the bus, the messages of the sender and the receiver. The messages of the small at most 8 data bits are protected by the checksum. So in this bus system we can get 8-bit layer of the messages in encrypted format. So we can capture that through the UDP protocol with the physical layer of this bus systems and the signals, and debus session. So we can see what is debus session. So in this debus session, so in this name of the file, machine ID, or else display the number where the machine ID is a randomly generated number stored in a variable library. So how many variables or how many numbers or how many characters or integers or else floats are be stored in the UDP protocol or any transmission protocol or physical layer, that should be stored over there. So it will be visible here on display the number of things. So we can see a briefly a clear picture. So I can show you. So here is the clear picture of this thing. So you can see the clear picture. So here is 127.0.0. So you can see test case, the test case post request data case, dealing default, the step calling program pre-send. So if you are sending some data, so it will be captured through the UDP protocol, and it will be listening in your local host. So check failed connection reset. So this is the file, and this is the binary thing. If you can encode the binary code, you will get the real message. Test step, sleep between test. So there will be a sleep between like 10 seconds to at every 10 seconds. So closing the target connections. So when you start the communicating with one person to another person in the applications layers, it will be close the connections, and contact the monitor, checksum pro man post sent. So you can see everything here totally it was displayed. So thank you for watching. Have a nice day.